Hello. All right, so today we're going to look at notes on the product rule and the quotient rule. And so we talked about the power rule. When you find a derivative of a function or the slope of a tangent line of a function, you can use the power rule, right? You multiply the coefficient of the term by the exponent, and then you subtract 1 from the exponent. And we said that we can do this if I'm adding terms or if I'm subtracting terms. But what happens if I'm multiplying terms? Okay, well then the power rule doesn't work directly with that product. And so I have a rule for you. It's if f and g are differentiable functions. Differentiable, remember, means that I can find the derivative of f. I can find the derivative of g. Okay, then the product, f times g, is also differentiable. Okay, so if I can find the derivative of each f and g separately, then I should be able to find the derivative of the product. So here's what the product rule states. It says that if I have two functions being multiplied together, so if y is equal to f of x times g of x, okay, I have these two terms that are being multiplied, then in order to find the derivative, so y prime, okay, would be equal to, well, unfortunately, it is not f prime times g prime. I cannot simply find the derivative of each term and multiply those derivatives together, okay? Instead, I would find the derivative of the first function or first term, and I would multiply that by the original second function or second term, okay? So f prime times g plus, I would then find the derivative of the second term or function and multiply that by the original first function, okay? So the derivative of a product, y prime, is equal to f prime times g plus g prime times f. And I'm going to write this in words. We have that y prime is equal to, I'm going to say derivative of the first function or term, okay, times just that second function. Okay, nothing fancy with that second function. I'm just rewriting that second function. Plus, now I'm going to find the derivative, I'm going to abbreviate, the derivative of the second function times that first function. Again, nothing fancy with the first function, just a direct rewrite of that first function. Okay? So I like to get things in mathematical notation, and I like to get things in words because our brains all work differently, and it's good to see different representations. So I'm going to go through these examples with you to see how this works. It says find the derivative of each function. We'll take a look. I have h of x equals x squared. That's one function, and it's being multiplied by a second function, 9x plus 2. Sorry. There we go. So I have two functions, okay? It's like my f function is x squared. My g function is 9x plus 2. And I am going to have to know what the derivative of each of these things are. So f prime, the derivative of my first function, based on the power rule, is 2x. G prime, again, based on the power rule, the derivative of 9x is just 9. And the derivative of the constant 2 is 0. Okay? I'm going to put these things together to apply my product rule. So if I'm looking at the derivative of h, I'm going to say that h prime is equal to, okay, the derivative of the first function, so the derivative of x squared, which was 2x, times my second function. I'm just going to rewrite that second function, that g function, plus, I apologize, I'm out of space. I'm going to write my plus below. The derivative of the second function, so the derivative of 9x plus 2, we said was 9 times a rewrite of my first function, which is x squared. And I'm going to clean this up a little bit. H prime of x is equal to, let's see, 18x squared plus 4x plus 9x squared. And I can clean this up just a little bit more. 18 and 9 is going to give me 27x squared and then plus 4x. Okay, so this would be my final answer. Now, you do not have to do what I did in the blue and the red. You do not have to write the function and then write the derivative. If you can remember this process and what piece goes where, you can jump straight to this. Okay? You do not have to do this right here. Although some of you guys might find it really helpful to organize your information that way, so you have the information ahead of time to put them into the proper pieces, but that is not a requirement. In fact, I'm not going to do that for number 2. Okay? So let's talk about number 2. Number 2, again, has this product, right? This is my first function, or my f function. This is my second function, or my g function. And again, I'm looking to find the derivative of this product, okay? And in order to find the derivative of this product, I have to do the derivative of the first, okay? So the derivative of 2 is 0, and the derivative of x to the negative 1 is negative x to the negative 2. And I'm going to multiply by the original second function. Okay? Plus, now I have to take the derivative of the second function. Well, the derivative of x to the 3 halves is 3 halves x. Subtract 1 gives me 1 half. The derivative of a constant is 0 times, now I need to write the original first function. Okay? So again, I could do what I did in the last problem where I wrote out the blue and the red. I don't have to do that as long as I can remember which piece goes where. And then my last step would be to go ahead and simplify this. So I would need to distribute. And the thing to remember when you distribute is that when you multiply like bases, like these x's, you add the exponents. Okay? So I get negative x to the negative half. Okay, and then I get minus x to the negative 2 when I distribute. And here, I'm going to get 3, so plus 3 x to the 1 half. And then plus 3 halves x to the negative half. Right, again, when I multiply those x's, I add those exponents. And the only thing I can clean up here are the terms that have the negative half exponent. Okay, so when I combine the negative, the x's with the negative half, I get negative 1 plus 3 halves, which is 1 half, x to the negative half. And then I'm just going to rewrite all the other pieces. I have minus x to the negative 2. I have plus 3x to the 1 half. And because the problem had negative exponents in it and rational exponents in it, you could just leave it right here. Unless it further states, unless the directions further state that you want no negative exponents and no rational exponents. If that's the case, then you would have to simplify this further. And if you want to know how to do that, ask me in class, and I will remind you how to simplify that further. All right, so question 3, again, I have this product in question 3. I have t squared times e to the t, okay? And again, I wrote this in a different way. I have d dt of that function. That means take the derivative, so the top part, that d, says take the derivative of t squared times e to the t. The bottom part says where t is the independent variable that's acting as our x. And again, I have this product. Now, I don't have to write anything with prime notation. I can simply write equals. Taking the derivative of this function is what I'm doing. So I don't have to indicate that my result is the derivative. The directive, the d dt, tells me to find that derivative. Again, I'm going to do the derivative of the first function. So the derivative of t squared is 2t. And then I'm going to multiply by that second function. Plus. All right, now I need to take the derivative of e to the t. And as we discussed in class, the derivative of the e function is just the e function. So The derivative of e to the t is just e to the t. It's one of my favorites. The derivative is itself times a rewrite of that first function. Okay? And that's really it. There's nothing I can do. But one thing I want to call to your attention is what AP likes to do. If there's a common factor, especially with e's, they like to factor out that common factor. Okay, so e to the t is a common factor. You might see this written as e to the t. And yes, while they both share a t as well, oftentimes you'll just see that e to the t pulled out. That would leave me with a 2t plus t squared. So that's another potential way. When you see multiple choice, oftentimes in the multiple choice they like to pull or factor out that e function. Okay, but this would be okay as well. All right, 4 says use the table to evaluate f times g prime of 7. And so what this notation is saying is that you need to do the product rule to find the derivative. You're going to write the derivative of this product of 7. Okay, and so I'm going to write that what I'm trying to do is find the derivative of this product at 7. So again, my first function written is f. So I'm going to do f prime specifically at 7. I don't have an actual function. Like there's no function to take the derivative of. And so since I have no function but a specific value, I'm going to say find the derivative of the first function at 7 times just the second function at 7 plus find the derivative of the second function at 7 times just that first function at 7. Okay? So again, I'm still going through this rule. I'm just going to evaluate specifically at 7. So f prime of 7 from my table is 2 times g of 7, which is negative 4, plus g prime of 7, which is 5, times f of 7, which is negative 9. Okay? And that gives me a negative 8 minus, 45, which is equal to negative 53. Okay? Okay, last but not least, I'm still going to be using this table. Use the table from 4 to evaluate, and I'm calling this capital F prime of 7. Okay, so I have this capital F function to differentiate from the fact that it's not the little f function. So the first thing I would do is I would actually find the generic derivative of this. And again, I'm looking for a product, right? That's the whole point of this lesson. So look, I have 3 times x. That's one function. And I have f of x. That's the second function. So these are the 2 functions that I'm working with. Okay, so capital F prime of x is equal to the derivative of this product. So again, the derivative of my first function is 3x. That derivative is 3 times just the rewrite of the second function plus the derivative of the second function, so little f prime of x, times a rewrite of that first function. So what I like to do is I like to find the derivative generically, okay? Then I like to go back and fill in that what I'm really trying to find is capital F prime of 7. So now I'm going to go back and replace every x I see with 7. Some people try to jump to this step instead of doing the generic derivative, and it doesn't work out for them, okay? So again, I did the generic derivative of capital F. Now I'm going to go back and fill in all those x's with 7. And I'm going to use my table to fill in these pieces. So f of 7, looking at my table, is negative 9. Plus f prime of 7, looking at my table, is 2. Okay, times 3 times 7, which is 21. So this gives me a negative 18 plus 42. Oh, my bad, sorry, negative 27. Happens to the best of us. Plus 42 gives me 15. So capital F prime of 7 is 15. All right, so you're going to do quotient rule for your next video and be ready to practice with me on Monday.